All right, so this entire section is all about transformations of graphs of linear functions. All we're really talking about is how is the linear function moving. We're going to kind of go through some of the ways that it's going to move, some of the patterns, and kind of explain a little bit about why. I'm just giving you all a little heads up. So the first thing I want to look at is some of these concepts. So the first thing I want to make sure we look at is how they move horizontally and vertically. So you'll notice here the graph of y, which is the same as like f, f of x minus h here, is a horizontal movement. So anytime you have inside the parentheses here, instead of it being like f of x, it's f of x minus h. Okay, we're talking about a horizontal movement. If you notice down here, we have the black, which is the normal f of x line, y equals f of x. Okay, this is normal, just slope of 1 with a y-intercept of 0. That's that black line. Okay, um, if we end up subtracting a negative number, okay, so f of x minus h, if h is negative, this actually ends up becoming a positive. Okay, ends up being a positive. If you just want to switch it up and say technically x plus a negative, well, that means it's like saying minus h there. You can kind of look at it that way if you want to, but understand that if it's supposed to be f of x minus h, if the h is negative, okay, a negative and a negative is technically a positive there, but if it's h is negative, we need to move to the left. So if it was f of x minus 2, okay, negative 2 there, we end up moving 2 to the left, okay, to the left there. Where if it's a positive h, the blue one, say it's like 3, so it'd be x minus 3 here, it'd be actually moving right 3. All right, so long story short, to summarize, or horizontal translations involve moving left or right. Okay, if h is positive, okay, we're moving to the, if h is positive there, we're moving to the right, whereas if h is negative, we're moving to the left. Over here, that's why I put the double negative there. Over here, you'll notice that the k is outside of the parentheses. So f of x plus a k. K is a constant there. It won't be 0, it's just going to be positive or negative. So if the k is greater than 0, we're moving up. If the k is less than 0, we're going to be moving down that amount. Okay, so if it was the k was positive 2, so f of x plus 2, we're moving up 2. If it was f of x minus 3, it'd be moving down 3. So what does that kind of look like? So let me look at some examples. Okay, so if f of x equals 2x minus 1, that's the original graph. Then we have g of x, which g of x is actually equal to whatever the f of x is. Then we're going to add 3 to it. So technically, we're going to move this up 3. Okay, so we got the whole thing. We move the whole thing up 3. Then you look at the letter b. T of x is equal to f of x plus 3. Now notice this one is inside there. It's referring to the x there. And because it's a plus 3, that's actually, remember what it was before, it was a minus and negative 3. Because it's a plus 3, okay, we're actually going to shift to the left 3. Remember, that was x minus a negative. A negative and a negative is a positive. So it used to be negative 3 there, right? Hence they show you right there. So we're actually moving there. So if h is positive, you're moving right. But if h is negative, you're moving left. But remember, it's a double negative. That's why it's positive there. Okay, hopefully that makes a little more sense there. Another example I want you to look at is dealing with reflections. Okay, reflections when it gets flipped over a line. So in this case here, the graph of y equals negative f of x is a reflection in the x-axis, okay, of the graph of y equals fx. So here's a graph right here. Okay, this looks like our y-intercept is 1 in this one. Okay, slope looks like it's 1 over 1. So we're going through here. Now, if we multiply everything by technically a negative 1, okay, we're going to be flipping that whole thing over the x-axis. So multiplying the outputs by negative 1 changes their signs and makes them all now have a negative slope. Okay. Now, if we want to reflect it over the y-axis, we do that to the x's, okay, to the inputs. So to summarize reflection, if you multiply by the, all the outputs by negative 1, okay, you're flipping over the x-axis. Whereas if you are multiplying all the inputs by negative, you're reflecting over the y. So you can kind of see the how it kind of looks. If you were to draw a line right through here, okay, it just kind of, sorry, right there, here's where it starts, but you can kind of reflect it through the x-axis here. And then over here, you're going to reflect it over the y-axis, okay, on this one. So what does it look like mathematically? Example 2. Let f of x equal 1/2 x plus 1. Graph g of x. Well, g of x is the whole thing's getting multiplied by a -1. So technically, yes, you can multiply this whole thing using distributive property and getting an answer of -1/2 minus 1. You can graph it. By all means, that'll work. Okay. Or you can technically multiply all of your outputs. Okay. Because f of x is an output. X is your input. F of x is your output. Multiply all your f of x's by a -1, and that'll give you your new one. So in this case here, your input's -4, -2, and 0. These are things that you pick. You can pick any one you want. Well, when you plug in -4 into the original, okay, you'll get -1. So you plug in -4 here, -4 times 1/2 is -2. -2 plus 1 is -1. That's where this comes from, okay? So now that you have your output, notice it's saying -1 times your output. -1 times your -1, and it's giving you +1. So we're actually going to be able to graph -4, 1, -2, 0, 0, and -1 because they want to know the point. You're always doing the inputs and whatever your output is there. Okay, for it. Letter B is going to be t of x. In this case, we're going to be multiplying the inputs here. Okay, you're dealing with the inputs. So we're going to go ahead and pull that one, and that's graph the other one. To the outputs, okay, so we have the -2, 0, and 2. Now, because the negative is associated with the inputs, the x's, we multiply this. -2 times 1, or say -1, is giving you a +2. 0 times anything, 0. And then 2 times the -1 is -2. Now, this ends up becoming your plug-in. So now this is what it's asking for you to do. Now, plug this number in into your f of x. There, plug that in, and that gives you your output now. So your input will be -2, 2, 0, 1, 2, 0. Okay, those are your graphs you're going to use. So you plug those points in, -2, 2, notice left 2, up 2, that one, 0, 1, 0, 1, and 2, 0. So it kind of gives you a little highlight on what it kind of looks like when you plug them in. So let me give you one to kind of play with ahead of time. So using the graph F, graph A, G, and B, H. Describe the transformations from the graph. So here we go. We have f of x is 3x plus 1. That's the original function. Y-intercept at 1. Slope is 3 over 1 is 3. So what do they want us to do? The g of x is actually equal to what the f of x is. Only thing is subtract by 2. So take this, move it down 2. That's going to be the g of x. For the h of x, since it's x minus 2, that means it was plus 2, it's going to shift right 2, okay? So in this case here, we have the first one, a, which is going to be moving, here's the original right there, the top one, and we shifted all of it down 2. Notice that they're still parallel because they're same slope. Down here, okay, we have our original, 3x plus 1. Now, because it's minus 2, that means it was technically plus 2 for h, so it means we're moving right 2. For number 2, we have our original f of x equals -4x minus 2. They want us to multiply all of it, all the f of x by -1. So if you want to do the distributive property, by all means do it. Okay, so -1 times -4x is a 4x. -1 times -2, so technically be 4x plus 2. So we're going to switch from a negative slope to a positive slope. Okay, so you'll notice here we switched here on this one for letter A. The original is right here. Notice that we switched it around and now it becomes positive. And if you did 4x, plus 2, it would give you this one, which is that you see your y-intercept is 2, up 4. Notice it goes by 2s, up 4 over 1. Okay. Very critical to make sure you look at the units on these. Notice these are going up by 2s on the y-axis, and then you have the x-axis going over by 1s. Now over here on the letter B part of it, okay, the h of x, notice you have the original. Okay, we still have our normal original, -4x right here, -4x minus 2. Now they want us to multiply our inputs by negative. Okay, so because of that situation, you're going to go through all your inputs, okay, your original, so whatever number you use, whether you use 0, 2, 1, -1, you're going to multiply whatever x you get, multiply that by -1, and then plug that into your f of x, and that'll be your new output. And when you get that, you'll end up seeing that it ends up reflecting right over the y-axis, okay, for the other one. Hopefully that works out a little bit better. We'll do some more practice in class.